What's up everybody, Mr. Murray here with yet another video on simplifying trig expressions here on Mr. Murray's Mathland. You can't see enough of these problems, you can't see enough examples because everyone's a little bit different, and every time you see one you might pick up a new little trick and something you can do. So let's take a look at this first problem here, and the directions do indicate, not every problem in the world says this by the way, just a lot of the ones I tend to work with on these videos, but we should be able to simplify this down to a single term with at most one trig function and no fractions. Okay, so number one here, what is this asking us to do? Simplify 1 over 1 minus cosine plus 1 over 1 plus cosine. So right off the bat, some of our major strategies we say are maybe try to change everything into sines and cosines. Well, that's already been done. The only functions I have are cosines. The other thing, maybe do any identities jump out at you right off the bat? Is anything squared, like some Pythagorean identities? And nothing's squared here. So really what you're dealing with is we're just asking you to add these two fractions together. All right, no tricks here. How do you add two fractions? You need a common denominator. So I've got to make these two denominators the same. So this first denominator has 1 minus cosine and the other one has 1 plus cosine. Then I've got to multiply this one by 1 plus cosine of theta, which means that numerator needs to be multiplied by that same amount. Now it's just going to be multiplied by the 1 that's already up there, so that's pretty nice. This second fraction needs to be multiplied by 1 minus cosine of theta. So I need to multiply that numerator by 1 minus cosine of theta. And now I'm going to put them over that same denominator, that common denominator of 1 plus cosine of theta times 1 minus cosine of theta. And remember, when I add and subtract these kinds of expressions, I typically leave the denominator in factored form because I'm hoping maybe some of it cancels out. So I usually leave that factored. And up top now, on the left side here, you get 1 plus cosine of theta when you multiply that by 1. And you are adding this. Watch out if that's a minus, because that means you'd have to subtract this entire numerator. But I'm adding 1 minus cosine of theta to it. And now combine your like terms, actually add those numerators together. I'm still being good and trying to be methodical. There's certain steps you can skip sometimes, but you don't want to skip too many here. You want your work to be clear. When you combine those two like term, two numerators, 1 plus 1 is 2, and cosine minus cosine cancels each other out, so you're just left with a 2 in the numerator. Okay, so here is where, like I said, I normally leave the denominator in factored form, hoping that maybe one of these or both of them will cancel, but I'm not left with any trig expressions up top. So since I'm supposed to be able to simplify this down to a no fraction kind of expression, this is where I'm going to multiply out those denominators if you haven't done so already. So that's just a little quick FOIL, or these are actually conjugates of each other, so you're going to get 1 minus cosine squared. And now that's not one term yet, but because you've made a squared, now you should be thinking about that Pythagorean identity, and that would be sine squared plus cosine squared is equal to 1. So 1 minus cosine squared would be just maneuvering that to the other side, and 1 minus cosine squared is always equal to sine squared. So this is what could be going on in your head. You wouldn't need to show me this little scrap work here, but I'm going to take out 1 minus cosine squared and I'm going to replace it with sine squared. And that's looking a lot nicer. Now it's down to just one term in the denominator, but the directions also said, hey, we should not have any fractions. Well, that's no problem, because now that that's just sine squared in the denominator, I can bring it to the top and name it by its reciprocal function. So the reciprocal of sine is cosecant. So this would be equivalent to 2 cosecant squared of theta. And there we go. Or if that sort of just moving it to the top and renaming it as its reciprocal, if that doesn't sit well with you, you can do the whole, that's really 2 divided by 1 over cosecant squared. That's what sine squared is. And then you multiply by the reciprocal of the denominator, which is cosecant squared over 1. And, you get the same thing. So some people like to show me that work, and that's totally fine. But I'm 100% comfortable with you just doing that maneuver, moving it to the top and renaming it. Okay, so very good. There's one problem that caused us to add fractions, so we had to make common denominators. Hopefully that's not too irksome for you. And I'll take a look at number 2. Number 2, a little bit more advanced. Still talking about adding 2 things together. One thing that really should jump out at you right off the bat is this negative theta. We typically want all of our arguments to be the same. So this is an even odd identity, and if you don't know them, hopefully you might, but you could at least look it up if you're on the lookout for it. And tangent along with sine is an odd function, which means the tangent of negative theta is equivalent to the opposite of tangent of theta. So I can take out tangent of negative theta and replace it. And when I put a negative, just picture putting negative tan of theta right there. It's kind of awkward to have a negative in the denominator. What I'm just going to do is change this plus in the middle to a negative, and then tangent of theta. See, so all I did was take that out and replace it with negative tangent of theta, and I just pulled the negative out in front. So now it's like I'm subtracting these 2. Okay, so where to go with this one? Remember, I don't always know the best or the fastest way to do it. I'm just like you. So what's jumping out at me right here is I could do one of 2 things. I could either try to make a common denominator here by multiplying by tangent. That might not be bad. I'd have to multiply this numerator by tangent. Or you might look at this fraction and say, I think this could be simplified to something smaller first by maybe rewriting these in terms of sines and cosines, and maybe this whole fraction could become something a lot easier to deal with. But I'm going to go with that first strategy, and maybe I'll come back and do it the second way to see if that works out better. But I'm going to go with that first strategy, which is let's try to make a common denominator with these 2, put them together, see what we got going on. So that means I'd have to multiply this by tangent of theta, which means I have to multiply the top by tangent of theta. And it helps, of course, if you can kind of see ahead a little bit where you're going. That now they'll both have that denominator of tangent, but this numerator on the left becomes tangent squared of theta. And when you put those together over that common denominator of tangent, tangent squared minus secant squared. Okay, well, those are not really like terms that can be combined in a traditional way, but they are squared, and they do both belong to the same Pythagorean identity. So maybe you've already been thinking ahead that, hey, 1 plus tan squared is equal to secant squared. So tan squared minus secant squared is equivalent to, just picture manipulating that equation, so bringing secant squared to the left, but that means bringing the 1 to the right. That's equal to -1, right? So take that apart, take that away. It's just kind of looking ugly, spilling into my work there. But I'm going to take out those 2 terms right there, and I can replace with a -1 over tangent of theta. And wow, that simplified things a lot right there. And again, similar to the previous problem, no fractions in our final answer. So instead of having -1 over tangent, I'm going to bring this to the top and rename it as its reciprocal function. So that would be a -1 times cotangent of theta. And there we go. So I think that was probably the best way to go there, making that common denominator. It was pretty painless because I saw that it was going to make a Pythagorean identity and allow me to simplify pretty quickly. So there we go. I am going to try that second way though, just to maybe show you, if nothing else, a different way that it could be done, because maybe you would have started down the road this way if you were doing it. And just to show you, a lot of times if you just are persistent and go with it, that can happen. So here's where I was after this first step. I'm going to keep that the same, where I swap the tangent of negative theta. So I'm at tangent of theta minus secant squared over tangent of theta. Okay. Now I'm going to take a couple steps and simplify this right here. So I'm going to leave this tangent of theta totally by itself. I'm not going to do anything with it yet. But secant squared, I'm going to rewrite that as sines and cosines. Secant squared is 1 over cosine squared. And in the denominator, tangent is sine over cosine. Now, can I simplify that big fraction? That would be the numerator, 1 over cosine squared, multiplied by the reciprocal of the denominator, which would be cosine over sine. And that's going to allow a little bit of simplification. That cosine there will cancel with one of those. I still have this tangent, which I haven't done anything with. But since that cosine canceled, that means you're going to have minus 1 over cosine of theta sine of theta, which, you know, doesn't look great, but hey, we're going to go with it. And here's where, if I were doing it this way, now I'm going to rewrite the tangent here in terms of sines and cosines as well. So tangent is sine over cosine, sine of theta over cosine of theta. Now I'm going to make a common denominator, see, with this, and I kind of see where this is going. So I need to multiply this denominator by sine of theta, right? Because that'll make cosine sine, cosine sine. So I'm going to leave that second fraction alone. So that's going to be cosine of theta, sine of theta in the denominator. And up top there, that's going to be sine squared of theta, when I do that sine times sine, minus 1. Now, sine squared of theta minus 1, that's a Pythagorean identity, right? Sine squared plus cosine squared is equal to 1. Some of these manipulations you should be getting pretty good at doing them mentally. So sine squared minus 1 is equal to negative cosine squared, right? I'm going to take those two terms out, replace it with that. So this is going to become negative cosine squared of theta divided by cosine sine. I see I can now cancel one of those cosines, right? Cosine from the denominator cancels with one of those cosines up top, and you are left with negative cosine to the first divided by sine. And here's where you really should say, hey, cosine divided by sine, that is cotangent. So I would say that way was definitely a little bit more work, but we got there, and it wasn't crazy amounts of work, and it used some good strategies to brush up on. So just to show you, you sometimes have totally different options, and as long as you're persistent and use good math, you can get to the same spot. So hopefully these two problems showed you some stuff, and if you have any questions, let me know. Keep working hard.